Dictionary associates some key with some value. If we associate that key with that value and then we ask for the key, then the map should return the value. Just like mathematical mappings map a function to a value, it's the same type of idea. So, for example, if our map was actually a dictionary, like an English dictionary, the keys would be the words and the value would be the definition. So if you wanted to know the definition of aardvark, you would look up the word aardvark in the dictionary. You put aardvark into the dictionary, and the result, what you get out, would be the definition of aardvark. So that's what a mapping is.
Then when it comes to the keys, like how you were saying, is that dealing with like enumeration as well, or no?
The keys can be any type. So they could be enumerations, they could be strings, they could be integers. There's many ways to build a map, and they're all valid mappings. Yeah, that's a word. They're all valid mappings. The implementation is going to vary a lot. So we haven't gone into the implementation. We are going to do that eventually. But the basic idea is we have some key, which can be any type of value. They can be any type, and some value, which also can be any type. So it's a general concept. We haven't gotten into the code yet because it's a little bit more complex.
Okay.
Does that answer your question? Okay. Who's next? Remember that I'm blind. Yes. What chapters were we covered in this quiz? The assigned readings from Zybooks were 8 and 9, and then there were a couple of sections from Cengage as well. They are all listed in the modules on Canvas. It's basically the stuff that I covered in lecture, and just, it's the readings on that stuff. Okay, yes? Will there be any math-based problems? If you're in computer science, there can always be math-based problems. The answer to that question will always be yes. So I'm just adding a shortcut here. Yes?
Do we have to know those iterators?
You have to know the iterators. Basically, anything that we covered in the lecture or that's in the books is fair game. So, anyone else? Way of Wildly for the blind man.
Oh no.
Okay, yes, go ahead.
So for the arrays, when you have a certain type array, an integer type array, is there a way to organize it in a sense, as in organize it from these arrays, or there's built-in like sort function?
Yeah, so the question was, is there any way to sort arrays? And the answer is there are ways to sort arrays. There are many algorithms which we might get to in this class. If not, you will definitely get to it in future classes. There's also a built-in Java sort function, which you are not allowed to use on Project 2. But yes, there are many ways to sort arrays. Does that answer your question? Okay. Anyone else? Yes?
Can you give a quick definition of a for each loop?
A quick definition of a for each loop. A for each loop allows us to go through a collection or a container of elements one by one. That is its primary function. Make sense?
Yeah.
Yes, go ahead.
Access enumerators from the main method. Enumerators is not static.
I'm sorry, I didn't catch one part because people were talking.
How can we access the enumerator from the main method? The enumerator is not static.
Oh, okay. So how do you access an enumerator in the method if the enumerator is not static? I believe, I see what you're saying. You're saying we can access them. How come we can access them? Right. And the answer is because the enumeration, technically what we're doing is we're defining a class. We're not actually defining a variable, we're defining a class, which we're going to get into today. We're going to talk all about classes, but that's the basic reason. I can definitely get into more detail, but I would be hesitant to do so before the quiz, because that is definitely not going to be a question I will ask. Good? Okay. And if you have questions after today's lecture, then let me know and I'll follow up. Okay. Anyone else? Going? Yeah, yes, go ahead.
Can you explain continuous statements?
Continuous statements, that's a good question. So a continuous statement, what it does is it finishes prematurely this iteration of a loop. So basically it says, stop this execution of the loop and go to the next one. So if it's a for loop, it means it'll increment the value and go to the next one. If it's a while loop, it means it will start over at the top of the loop. That's basically what a continue statement does. That's different from a break statement because what a break statement does is it gets out of the loop entirely. So continue says go to the next iteration. Break says stop the loop right now. Yes?
So continue will go to the next iteration, but break will stop the loop overall.
Yes. Continue will go to the next iteration. Break will stop the loop. Yes?
Does break work for the methods?
Question is, does break work for methods? It does not, but return works for methods. Yes?
Will continue check if a while loop is true or false?
Oh, that's a really good question. If you execute continue, will it check the condition of the loop? And the answer is yes, it will check the condition. It doesn't short circuit the condition check, it just short circuits this iteration of the loop. All right, anyone else? Going once?
Wait,
Yes, go ahead.
if you do a for while and if you do continue, it checks it still?
Yes, even if it's a for, if it's a while, if it's a for each, all of them, it's going to check any condition.
Okay.
Yes.
What's the difference between a hash map and a tree map?
Oh, what's the difference between a hash map and a tree map? First of all, I will not ask that question on the quiz, but I'm going to answer the question. The difference is how they're implemented underneath, and that impacts their performance. So we didn't go into the details because it's pretty complex computer science, but the basic idea is they are optimized differently. A hash map is optimized for best case average access, while a tree map is optimized for best worst case performance. So even in the worst case, a tree map performs at a certain level, but that sacrifices the average case to make that happen. Yes, go ahead.
If you have a while loop and then an if statement and then a continue, which one does it break? Does it break the if or the while?
The question is if you do continue or break inside of an if, what does it break?
But wait, it's in a while loop.
Inside of a while loop. So if you have an if inside of a while loop, which one does it break? Well, break and continue never apply to ifs. They only apply to loops. All right, going once. Yes.
So the difference between for and while loops are just basically like for has everything built in the top, and you don't have to like iterate it and everything.
Yeah, the question was, so the difference between for loops and while loops is that the for loops just has everything built in to make the loop iterate and count, and the answer is yes. That is exactly the main difference between them. Going once, going twice. Okay, last question. Okay, we'll take one more. Go ahead.
With do while, what would happen if you just did the do first and just the while at the very end, or like?
Well, for do while, we always put the while at the end. It's always do and a block of code and then while. So it always runs that block one time before it even hits the condition check. Okay?
Your slide should have the other way though.
I'll have to double. I think I had while and then do while.
Yeah.
So those were two separate loops. Yeah, no, it's okay. All right. So, you ready to get this party started? No. Well, you don't consider a quiz a party? Is that what you guys are telling me?